Here's problem 1226. If 1 cubic meter of concrete weighs 5 times 10 to the 4 newtons, what is the height of the tallest cylindrical concrete pillar that will not collapse under its own weight? The compression strength of concrete is 1.7 times 10 to the 7 newtons per meter squared. This compression strength is what we would call the stress. It's equal to the weight per area, the force per area, but this would be the stress of the concrete. Alright, so if we were considering a pillar cylindrical of shape like this, let's say it has some length L and some cross-sectional area A. Based on that, its volume is equal to its cross-sectional area times its length L, and its mass will equal its density times its volume, which would be equal to the density times the area times its length. Sounds good? So we could say that the stress is equal to the weight per area, which is equal to mg per area, which for the mass would be the rho area times length times g over the area. So we see from this that the areas cancel out, and this would be equal to the density times g times the length, or density times g times length. That's it. So the length is going to equal the stress divided by the density times g. Now the density times g is the mass times g per volume, or it's the weight per volume, and the weight per volume is 5 times 10 to the 4 newtons per cubic meter. So this is going to be equal to the compression stress, 1.7 times 10 to the 7 newtons per meter squared, over the weight per volume, which is 5 times 10 to the 4 newtons per cubic meter. Alright, the newtons cancel out, and meters squares cancel out, and we're going to end up with meters. And this is going to equal 340 meters. So we can have a cylinder, a column of 340 meters before it starts to collapse under its own weight and exceed the stress in the concrete.